Okay, we are starting a new unit, and this unit requires you to use your factoring skills and your fraction skills. Fraction skills you learned in the 3rd and 4th grade. Factoring you learned last year, and we revisited it this year. You need to use those two things to deal with rational expressions. Now, before we go any further, I will tell you what indeed a rational expression is. First thing I'm going to highlight is the word expression, which means there is no equals sign, which means it cannot be solved. Okay? The only thing we can do with rational expressions is simplify them. Okay? Please remember the difference. X plus 7 is an expression. What is the answer to it? There isn't one. X plus 7 equals 9. That's an equation. There is an answer to it. Everybody good? So what we are dealing with are algebraic expressions. And these expressions are any ones that can be written. That is really annoying. As the division. Please understand when I say division of at least 2 polynomials. So what we are dealing with here are things that look like this. Cool? Binomial divided by a binomial. That's what we're going to be dealing with. Now, there's a couple of things we have to make sure everyone is aware of before we go too much further. I'm not going to define polynomial again. We already know what that is. I'm not going to write it out. I'll say it, but I'm not going to write it out. Polynomial is, of course, any mathematical expression made up of variables and coefficients and constants. There's a couple of rules about polynomials that I'm going to get to in a moment. Okay? The other thing we have to be aware of is because it's division, there are some crazy rules we have to remember as well. Okay? So, for the first thing we have to remember is they are rational expressions. Rational means a couple of things. Rational means it's got to be in this form, y over x. It's got to be like that. And there's some rules about this. X cannot equal 0 because we can't divide by 0. Everybody understand? Now, you guys are smart kids. This is a rational number, yes? Because it's just an integer over an integer. X can't be 0. But in a rational expression, the denominator changes, doesn't it? It's not one single thing. So in a rational expression, this is a rational number, but in a rational expression, the denominator can never, please highlight, underline, do something to the word never, equal 0. And I'm going to talk about what I mean by that in a little bit. Okay? Everybody good? All right. Now there are some things that make expressions not rational. All right? Now notice I'm not using the word irrational because that's a slightly different thing. If it is not rational, these are the things that are not allowed. I can't have a variable exponent. That's not okay. Can't have it. That's not rational. All right? The other thing that we can't have is no radical variables. Because a radical variable is just an exponent with a variable, yes? That's not allowed. Now, this one causes trouble. And I don't want you to write down what I'm about to write in red. Please don't write it down. Just look and think about it. Is this okay? Is that a rational expression? Yes or no? Why do you think it is? Radical signs over the two, not the variables. Okay. Is the square root of 2 rational? Yes or no? So can that be a rational expression? No, so that's out. Because that is an irrational number, so that makes it out. Now, obviously the next thing I'm going to do is change it to this. Is that rational? Is that rational? No. There's no radical variables. Then I'm going to change it to this. Is that one rational? Why? Because 4 has a square root. Everybody cool? So you didn't have to write it down. You just have to be aware of it. Excuse me. Everybody good? All right. Now, the next thing we have to talk about is this. A non-permissible value. What does the word in English non-permissible mean? Huh? Not allowed, right? So in math, a non-permissible value is the value that we're not allowed to have. And what that is a non-permissible value is any value which makes the expression undefined. Now, who remembers what undefined means? Pardon? Not a real answer, right? Any value which makes the expression undefined. Now, undefined for us in most cases is anything over 0. Because that can't exist. All right? They get another name. They are also often called restrictions. Okay? So, how we find them is this. We set our denominator as equal to 0. And then we work it out. Is everybody cool? So, let's have a look at this very first one. What values here are not allowed? So first of all, I have to look at my variables. I can have t, I can have s, and I can have r. Is there any value for t which I can't use? No. T is all real numbers. Because I can take any number, multiply it by 5, and then divide that into chunks, can't I? Even 0. If I have no pizzas in front of me, and I multiply that by 5, How much pizza will all of you get when I divide it up between all of us? None. It works. Everybody cool? Now, what about S and R? What would not be allowed there? So what do? I set my denominator as equal to 0. So 4SR squared equals 0. Anything that makes that true is a non-permissible value. Okay? Anything. But there's only one number that can't go there. What is it? What, Max? Yes, it's 0. S cannot equal 0. R cannot equal 0. Because if either of those is 0, then my denominator is 0. Is everybody cool? Because it doesn't matter what the other one is, because this is all multiply. If R is 3,000 but S is 0, the denominator is still 0. That can't happen. Everybody good? Okay. So let's look at B. What are my options here? Well, I only need look at the denominator, yes? And x, 2x minus 3, cannot equal 0. Oh, I forgot to scratch out cannot equal 0. So what there would make this equal 0? You've already seen this in factoring. What isn't allowed there? What does this mean? Fortunately, I have a lot of coffee and 50 minutes left in class. I'll be marking tests till somebody comes up with something for me. Just holler when you've got it figured out. What is it? Excellent. 0 is not allowed there. Why? Because if x is 0, that's going to be 0 times this, yes? Excellent. Is there another one? Pardon me? Excellent. 3/2 is also not allowed. Why? Because if x is 0, x equals 0, then that's 0 times that, yes? But that also can't equal 0, can it? So 2x minus 3 can't equal 0. So 2x can't equal 3. So x can't equal 3/2. Nicely done, everyone. And finally, C. What are you going to do down there? Again, we only care about the denominator. So what can we do with that expression? Factor it. Excellent. What does that factor to? We factor it whenever we can. Who remembers how to factor that? Hopefully somebody. That is one of your answers. What does that factor to? P minus 4 and P plus 3. And that is this denominator, yes? So that cannot equal 0, which means P minus 4 can't equal 0, which means P can't equal 4, and it means P plus 3 can't equal 0, which means P can't equal -3. Okay? All of which you have actually already seen before, except here, up until now, we've been equaling 0 to find the roots of quadratics, haven't we? But now, we don't want to equal 0 because we can't have 0 on the bottom. Everybody good? All right. Turn the page over. I am going to write something up here that is going to scare you, but don't let it. Fractions are rational expressions. I know a great many of you live in fear of fractions. You run screaming from them as if they were knife-wielding murderers. You don't need to. Fractions are not out to get you. All right? But you need to be aware that all the rules that apply to fractions apply to rational expressions. Here is what I mean. How many of you in your head can add this? What is it? 4. Why? Because the denominators are the same, so it's 1/2 and 7/2, which makes 8/2, which gets us 4. Yes? Okay. How many of you can add this in your head? One. Excellent. Good. We are on a roll. What about this? 3/4. Awesome. We are on a roll. This is good day in math class. 2/3 plus 3/4. Ooh. Bad ass. Can you do it in your head? You don't have to be able to. I'm just wondering if you can. 17 over 12? Everybody cool with all that? Even if you didn't get to 17 over 12, you knew it had to be 12, yeah? Everybody did, right? Okay. So, if you're comfortable with that, you're ready to simplify rational expressions, okay? So, when a rational expression is in simplest form, you have heard that expression many, many times. In grade 4 with Mrs. Badcrumble, would you ever have left this fraction? No. What would you have written? 1/3. Would you have ever left this expression? No. What would you have written? 2/5. Excellent. What did you do to get 1/3 and 2/5? What did you do to those two expressions? You divided, but you divided 3 by 9? Yeah, you took out a factor, didn't you? So when you were learning to simplify, or as your teacher probably referred to it, reduce fractions, what you were really learning was factoring, wasn't it? Because you GCF'd this, right? You said 3 goes into 3, 3 goes into 9. I'm going to divide them both out 1/3, right? 2 goes into 4, 2 goes into 10, 2 and 5. Can you go any further there? No, because there are no what? What did I have with 3 and 9 and 4 and 10 that I do not have with 1 and 3 and 2 and 5? I don't have a common factor, do I? So, if that's how you simplify fractions, and fractions are rational expressions, then what must we do to a rational expression to put it in simplest form? What must we remove? All the GCFs. So, when a rational expression is in simplest form, the numerator and denominator share no common factors. Now, please, please, please highlight the word factors. Okay? And here's what I mean. We'll do a nice, easy one with just numbers. No letters, no polynomials, nothing. 32/48. Let's pretend you're real bad at simplifying. What's the first factor you're going to take out of there? Most of you are going to use 2, right? So you factor out a 2. Now, in your heads, you divide both by 2, don't you? But what are we really doing? It's actually 2 times 16, because that's how you factor, isn't it? You take out the GCF, then you put the answer there, right? And this one is going to be 2 times 24, yes? Now, what math is happening right there on the red dot? Multiply, right? Which means 2 and 16 are factors, aren't they? And 2 and 24 are factors, aren't they? Right? These 2's are common, yes? So I cancel them out. Now, am I done? No. What would be the next factor you would take out of there? Most of you would see 8 right away there, because we're getting smaller now, right? So that would be 8 times 2 and 8 times 3, wouldn't it? Are those factors? Do they multiply? Does 8 times 3 get me 24? So they are factors, yes? So 8 and 8 must be common factors, yes? Everybody with me? So they are gone. What is left? 2 and 3. Are there any common factors there? Factors of 2 are 1 and 2. The factors of 3 are 1 and 3. 1 is common to everything, so we don't count it. Is everybody good with that? Remember, there's what you do, which is I divided by 3, I divided by 3, I divided by 4, I divided by 4. And then that's what you're doing, but what you're actually doing is factoring. Everybody cool? So that tells us that we need to do 2 things. 1, we need to factor everywhere. And 2, we need to cancel. But let's remember, there's rules. And those rules are we can only cancel factors. And I'll show you what I mean right now. Okay? So, let's look at this first guy here. First thing I need to do is factor everything. what can I do on the top? I'm going to highlight it in yellow. In the numerator, what can I factor? The 3. How do I write that? Three x minus 2, correct? Now you got to think back to grade 10 to do this, because in grade 10, we just gave you 3x minus 6. So in grade 10, you don't need to write this down. 3x minus 6, we told you to factor that. Oh, okay, so you divided both sides by 3, then you put the 3 out front, and then you put the answers in brackets, yes? And that was the end of grade 10 GCF factoring, wasn't it? Now, it's the first step. Now, let's look at the bottom. What can I do on the bottom? Who remembers how to factor those? Yeah, you got to go 2 times 10, right? So you need to multiply to negative 20 and add to 1. What is it? Is it 1 and 20? 5 and negative 4. 5 and negative 4 to get 1. Absolutely right. So that would be x plus 5, but it's not really plus 5, is it, Priyanka? Because I multiplied by 2, right? And x minus 4. But it's not really 4 divided by 2. And then we simplify. The 2 goes to the front. 2x plus 5. And what do I do with this fraction? That equals 2. X minus 2. Right? Everybody cool? Now, is there a common factor? What is it? Are there any other 3s? Yes, it is x minus 2. So what do I get to do with factors that are common? What did I do when I was doing fractions? Cancel them out. So what do I do here? Cancel them out. Because x minus 2 divided by x minus 2 is 1, isn't it? So my final simplified answer is 3 over 2x plus 5. Can everybody follow me to there? Right? It's no different than regular fractions, yes? But we've added one wrinkle. How do I do that? When am I ever allowed to have a 0 in the denominator? Never. So, am I allowed a 0 in that denominator? No, I'm not. Am I allowed a 0 in that denominator? No, I am not. Even before we cancel, I'm not allowed a 0 there. So I have to check for my non-permissible values. We check for, and I'm running out of space, so I'm going to write NPV, non-permissible values, at the factoring stage. And I check for them the same way I always check for them. 2x plus 5 can't equal 0, and x minus 2 can't equal 0. Right? Now I'm going to give you a hint. Because when you solve this, you're going to move that 5 over, and 2x can't equal negative 5, so x can't equal negative 5 over 2, right? And in this one, you're going to move that 2 over, x can't equal 2. Everybody agree? Please notice that you had the answer right here. There's the 5 halves, but you had to change the sign. There's the negative 2, but you had to change the sign. Does everybody see that? While you are doing your factoring, you will find your non-permissible values without having to do this. Is everyone okay with that? All right. Let's look at B and see what we can do. Does the numerator factor? Does it? No. So the numerator is staying the same, 1 minus t. Does the denominator factor? Got to think back to grade 10. We reviewed it a little in grade 11. How do I factor that? It's a difference of squares, so factor it for me. If you do not remember difference of squares, it's the square root of the first one. What's the square root of t squared? T. Plus the square root of the second one. What's the square root of the second one? 1. And then you write it again. T minus 1. Right? Now, does any part of that look suspicious? Because right now, is there any canceling we can do? Why not? Are any of these the same? None of them? Yeah, you can. Because there is a number that is a factor of everything, isn't there? What is it? 1 and negative 1, right? Can I factor negative 1 out of here? So this on the top, if I take out a negative 1, then what happens to that positive 1? It becomes negative 1. What happens to that negative t? It becomes positive t over t plus 1, t minus 1. Now, is that completely factored? Yes or no? Yeah? It's completely factored. What do we do when we have it completely factored? What are we supposed to check for? The NPVs. So what are the NPVs? What is t not allowed to equal? T can't equal? No. If it's 0, then it would be 0 plus 1 and 0 minus 1. And the bottom would be negative 1. This appears to be causing problems. What's not allowed to be 0? The denominator, right? Which means t plus 1 can't equal 0, and t minus 1 can't equal 0. So t can't equal negative 1, and t can't equal positive 1. So t can't be plus or minus 1. Is everybody okay with that? All right. And now, finally, simplified. Is there any canceling we can do? Where? T minus 1 and t minus 1. So what is my final answer? Negative 1 over t plus 1. Is everybody okay? Please notice that it's exactly the same as fractions. So let's look at C. What can I do in C? Please notice, once again, the only new thing that you have been introduced to today is non-permissible values. Everything else you already know. What are you going to do with just that? Factor it. What does that factor to? We already factored it on this page. Right, it's right up above, isn't it? Except I used a different letter. So that is 2y plus 5 times y minus 2, correct? Okay. Over what's on the bottom. How do I factor that one? And please notice I am not reteaching factoring because everybody's got their own way of factoring. We've done a unit on it. What is it, Sukbal? Y plus 5 and y minus 2, correct? Am I at totally factored form now? Yes or no? Have I factored everything? What do I check for when I have everything factored? That's when I check for my NPVs. And my NPVs are where the denominator is 0, yes? So my denominator right now is y plus 5, y minus 2. Is not allowed to be 0. Now already you guys should be able to tell that without doing algebra. What is it? Right. Y cannot equal negative 5 or 2. Everybody good? Now, are there factors to cancel? Where are they? Y minus 2 and y minus 2. What's left? 2y plus 5. I'm going to talk about that right now, Max. Because I think that you're about to ask if I can cancel those 5s. Oh, I see. Okay, so you're going to ask about that. Can I divide here? I'm asking you. You feel I can? If y is 5, what's 2 times 5? Plus 5? 15. If y is 5, what's on the bottom there? 10. So this, if y equaled 5, would be 15 over 10, wouldn't it? Which would be 1.5, correct? Okay. If I cancel those, what's left? Is 1.5 2? So can I cancel those? No. Here's why. That's the one reason why. Why? But the real reason is this isn't factored, is it? Right? If it was this, Max, 2y plus 5 over y plus 5, could I cancel those? Again, watch what I mean. Again, keep y being 5. That would be 5 plus 5, right? Which would be 10, yes? Times 2 would be what? 20. I'd have 20 over y plus 5 is 10. What's 20 divided by 10? 2. Now, if I cancel those, what am I left with? 2. Picking up what I'm putting down? This is one whole unit. It's not 2 times y plus 5. It's 2 times y plus 5. Do you understand the difference? Yes. Does everybody understand the difference between 2y plus 5 and 2y plus 5? Everybody cool with the difference there? This is 2 different factors. This is all one factor. Everybody got it? Okay. So you guys try that one. What can I do up top? What can I do on the bottom? So what's happening up top? What should I bring out of there? 2? Okay. Might I suggest when you see a negative letter, because on the bottom I'm going to have no negative letters, am I? Might I suggest when you see a negative letter, it's good to take out the negative. Everybody understand? So if I take a negative 2 out of the top, what do I get? What's 6 divided by negative 2? Negative 3. So I'm going to write it over here. And what's negative 2m divided by negative 2? Positive m. Does everybody see what I did there? We don't like negative variables. Everybody cool? Now, what's the bottom look like? Is m squared a perfect square? So it's square root of m squared, which is what? M. Is 9 a perfect square? Square root of 9 is? M plus 3, m minus 3. Yes? Am I at fully factored form? What do I check for at fully factored form? NPVs, what are they? What is m not allowed to be? Plus or minus 3. Right? Now, where are my cancellations? m minus 3 and m minus 3. So my final answer is negative 2 over m plus 3. Is everybody good? Okay, we're going to do one more together, page 124, and then I'm going to shut up and talk about what you guys are going to do today and tomorrow. Now, when you guys are faced with these, the first thing that 99% of kids do right away is they take X and they put it in there, they take Y and they put it in there. Right? Now that's going to give you a decimal squared times 16, and then another decimal squared times 9. Then you're going to have to subtract it. Then you're going to have to multiply 8 by that decimal, then 6 by that decimal. Then you're going to have to divide it. Does that sound like something you want to do? No. Which is why we always start with that instruction. What are you going to do up top? Is that a perfect square? Yes or no? Yep. Is that a perfect square? So is that a difference of squares? So can we factor the top? What's the square root of the blue one? 4x plus, what's the square root of the green one? 3y. Then we write it again with the same factors but a different sign. Can I factor the bottom one, which is in yellow? Does there something shared between 8x and 6y? 2. So I'm going to bring out a 2. What's 8x divided by 2? 4x. What's 6y divided by 2? 3y. Am I now fully factored? Yep. So what should I check for? Non-permissible values. It's a little tricky, isn't it? Because the non-permissible values here is when that's 0, right? So 4x minus 3y cannot equal 0. Now that's weird. What's weird about that? There's two variables, correct? So 4x cannot equal 3y, yes? Which means x cannot equal 3/4 of y. Does everybody understand? Does everybody understand? And what else? Y cannot equal what? 4/3 of x. So what if this said x equals 0.75? Could we do this question? Look carefully. I did this on purpose. X can't be 3/4 of y. Understand? So keep on the lookout for that. What am I allowed to do here now? Cancel. What's left? 4x plus 3y over 2. Now somebody always says, why can't I cancel there? What's the answer? Because you can't cancel on the 3, can you? This is all one thing. Now, how many substitutions do I have to do? Just 2. And how many math operations do I have to do? Just 1, 2, 3, 4. How many did I have to do here? 1, 2, 3, 4, 5, 6, 7, 8, 9. I had to do 10 operations. Or I have to do 3. Which way is easier? Right? Which one can you do in your head? I bet, even with the decimal, you guys could do this one in your head. I bet. Can you? Really? That's 10.4 plus 3.6 over 2, which is 14 over 2, which is 7. You guys could have done that. Yes, you could have. Don't be that way. Right? It's not like I'm asking you to get on a bus, Max. That's complicated. All right, now listen up. It's 9:14. Here's what I want from you guys. It looks like a crap ton of work, and I'm giving you now and tomorrow's class to do it. But before I go too crazy, if you flip all the way to page 127, what do you see? They're all there, okay? So by the end of tomorrow's class, make sure that you can get all of these answers when you do all of these questions. Okay? I believe it's 24, 25, and 26. And then the answers live on 27. Okay? Now, with any luck, well, not with any luck, it'll certainly be done by Friday. On Friday, we'll be going over this test. Okay? Everybody good? It'll be on Check My Mark sometime today. Probably by the end of lunch. Any questions? Do I care if you start right now? No. But, you hear the level of noise in this room? It shouldn't go much higher than that. Alright? Especially if you're not going to do your math. Because then if somebody walks by, nobody's going to know. Picking up what I'm putting down? What should you be doing? You should be doing as much of this as you possibly can while you have me here who can actually help you. Because who knows who tomorrow's TOC is going to be? It could very well be. I don't know how good Mr. T is with rational expressions. Okay then. He'll be able to help you. I don't even know who that is, except that he's a Leafs fan and he doesn't like that I don't like the Leafs. I don't know which one of you guys ratted me out, but it was somebody in this class. I bet it was Josh, because Josh is a stinking Leafs fan.